Hello everyone, welcome to Gchem classes. So today we are going to see the quantum chemistry. So it will be atomic structure, okay, as well as quantum chemistry, okay, because directly they are not asking any like more questions in quantum chemistry. They are mixing with your atomic structure, right? If you see your IIT JAM syllabus, unit number 1, it is your atomic structure and molecular structures, right? In that only they have given some of quantum chemistry. So for you IIT JAM, it is not that much vast, okay. Simply we will see whatever is requirement for your upcoming examination, that much we will see it. So we will start it with Bohr radius, okay. These are the small these are the formulas which you just write it down in some paper, okay. Give 2 or 3 revisions. This will be, you will be remember till this Sunday, okay. If you are writing down in a paper and you are just looking 2 or 3 times, you will be perfect in those formulas, and directly with those formulas they are asking questions, okay. They are not modifying these things because they know that this is the boring topic. That will be the advantage, right? If you are able to solve this type of questions, it will be an advantage, because it is not like that you won't understand. The thing is that it is like you can't relate with your daily life, right? That's why you feeling this topic is boring, correct? So let me first discuss Bohr's radius. What is Bohr's radius? Okay, it will be 0.529, okay, 0.529, and then whatever I am writing, it is in angstrom I am writing, okay, and then it will be n square by z, and it will be in angstrom. If they are giving in, suppose they are giving in picometer, then how much it will be? It will be 53 picometer n square by z, okay. That will be in picometer, correct? Because 2 places it will go right hand side, okay. So it will be picometer, because angstrom is 10 to the power minus 10. If this one you are converting to the meter, it will be 10 to the power minus 10 meter. And if this one you are converting, this 53, it will be 10 to the power minus 12 meter, correct? So this unit conversion also, it is very much important to like in correct way you should convert it, otherwise it will be problematic, right? Instead of 53 picometer, you will write 0.0053 picometer, okay? So that unit conversion might be asking in this type of question. They will just change the unit and then they will ask, right? This is the Bohr radius. Suppose they are asking for first Bohr radius for hydrogen atom. What will be the first Bohr radius for hydrogen atom? It will be 0 in picometer. It will be 53 into n is orbital number for hydrogen, like hydrogen atom orbit number 1, right? So because Bohr's call it orbit. Bohr's call it orbit, okay, but this is not orbit, right? That is stationary state, the energy state, it called it orbit, right? So n equal to 1 square, and for atomic number, what is the atomic number for hydrogen? It is 1, right? So everything will become 1. So now 53 picometer is a first Bohr radius for hydrogen atom, right? So likewise for helium, if you are writing for helium, how much it will come? It will be 53 into, again for helium, only first Bohr orbit is there, okay, 1s2, right? 1s2. So the first Bohr orbit only is, okay, n equal to, it will be 1 for helium also, right? So now 53 into 1 square divided by, here the z atomic number, right? Atomic number is 2, helium Bohr radius, okay, because electron is increasing, so that attraction between electron and proton will increase, right? That's why that size is getting decreased, correct? So likewise this is for Bohr radius. Okay, slowly we will move towards the quantum side, okay. So now the energy of electron, how to find the energy of an electron? Okay, energy of electron. So E equal to minus 13.6, okay, z square divided by n square, and this is in electron volt, okay, this is in electron volt, and we know that 1 electron volt equal to 1.6 into 10 to the power minus 19 joule, okay. Based on this formula, I have seen they have asked question in I guess in 2022 or 2020, maybe they have asked one question, okay, like hydrogen and helium, okay, the ratio of energy. So ratio of energy, everything will be fixed. For hydrogen and helium, n will be same, both will have first orbit element only. So here it will be 1 square. For only Z it will be changing. Okay, for hydrogen it will be 1 square, and for helium it will be 2 square, correct? And then ratio you have to count. Okay, so this formula you just write it down somewhere. Okay, and this conversion also, electron volt to joule or joule to electron volt. So this type of conversion you just write it down in some paper. Okay, in this unit just you have to work up with the formulas. Okay, they will ask directly question. Next we will see velocity of electron, correct? So we will see velocity of electron. They have not asked. Okay, might be they are asking in this upcoming examination, because electron, energy of electron, based on that energy of electron they have just asked the ratio helium and hydrogen, right? So maybe in this time they may ask velocity relation, correct? So it will be like velocity of electron, it will be Z into 2.188 into 10 to the power 8 divided by n. Okay, this will be in centimeter per second, correct? So Z atomic number, again atomic number, n orbit. Suppose for hydrogen it will be 1 and here it will be 1. For helium it will be 2, here it will be 1. So now for helium it is now it is double, right? Double than hydrogen. The velocity of helium it will be double, because here it will be 2 into entire thing, and for hydrogen it will be 1 into entire thing. So it is just doubling for the helium, right? The velocity of electron, correct? So likewise the comparison they might ask you. Next we'll see hydrogen spectrum, correct? Okay, so hydrogen spectrum we'll see. Here also we'll come to know some new fact. Okay, because just I am giving you a revision, not a regular class. In regular class each one will be explained in well manner. Okay, so this is n equal to 1, this is n equal to 2, n equal to 3. These are the energy level, right? N equal to 4, or you can say principal quantum number. Okay, shell number, because positive will be somewhere here, right? And then this will be cell 1, this will be cell 2, cell 3, cell 4. Likewise n equal to 5, n equal to maybe infinity. Okay, so just see if any radiation is falling, like this is a emission spectra, right? In hydrogen spectrum, first you have to excite it to the infinity or somewhere else, like n equal to 5 or n equal to 6 it will go, and then while coming back, so this is a emission spectra. So while coming back, if it is directly falling to the n equal to 1, okay, then that series will have some different name. If it is falling n equal to 2, it will have something else. Okay, some other name, n equal to 3, n equal to 4. Likewise the names are there. So suppose n equal to 1 it is falling from infinity, or maybe from n equal to 5 to n equal to 1 it is falling, n equal to 4, okay, from n equal to 3 or n equal to 2. So this series we call it Lyman series. Okay, Lyman series. And see the energy difference. This will be the more energy difference compared to if same place, if it is falling down to n equal to 2, right? If from same place it is falling down to n equal to 2, so this will be the energy gap. This is energy, right? So this will be the energy gap, and for this n equal to 1, this is the energy gap. So which one is more? If it is falling to the n equal to 1, the energy will be more, right? So we call it, it is in UV region, because UV I know UV we know that it has minimum wavelength, okay, lesser wavelength, but it has more energy separation, like more energy, more energetic, right? And then in the next series what will happen, if it is falling to n equal to 2, okay, if it is falling n equal to 2, we call it Balmer series. Okay, we call it Balmer series, and it will fall under visible, because you will see the color. Now if I'll mark it 1, 2, 3, 4, and if I'll ask which one is a red color and which one is a blue color, okay, just tell me which one is a red color and which one is a blue color. Just comment it, okay. Likewise also they might ask you question, okay. So in Balmer series, so energy is falling from n equal to infinity to 1, n equal to 5 to 1, n equal to 4 to 1, n equal to 3 to 1. So which one will be your red wavelength, or which one is the particularly blue wavelength? So this type of question also they might ask you. So just tell me which one is a red and which one is a blue. In a comment section you just tell me, okay. So see, this energy gap, you see, it is a minimum, right? From n equal to 3 to n equal to 4, energy is minimum. If energy is minimum, wavelength will be more, right? And see this one, n equal to infinity to n equal to 1, right? So here the energy gap is more, okay? So it is more energetic. It means the wavelength will be lesser, correct? So we can say this one will be blue and this one will be red. So this will be like blue to red, means from this side to this side wavelength is decreasing, but energy is, wavelength is increasing, but energy is decreasing, correct? So if in Balmer series, suppose same thing, if it is falling from here to here, okay, everything is falling here, what we call it, this one, question. Okay, this will come under IR. Then if it is falling under here, we call fund, okay, F-U-N-D, P-F-U-N-D, fund. This will also fall under IR, okay. Here if it is falling, then it will be bracket, okay. So it will also belongs to IR. So this is the spectrum, okay. Now if they are asking based on Rydberg constant, you write it, this energy, n equal to 1, n equal to 2, n equal to 3, n equal to 4. So how you are going to write with the Rydberg way of writing? So just we'll see the frequency. First we'll write the formula and then I'll tell you how to fill up with the based on the Rydberg constant, okay. So this new bar is 1 by lambda, right, wave number. So it is like RH and then 1 by n1 square minus 1 by n2 square. And what is this n1 and n2? n1 is this one, n2 is this one, okay. So n1 square minus n2 square, correct? This is for hydrogen, okay. This is for hydrogen atom, and other than hydrogen, how we are going to write? Other than hydrogen, okay, for other than hydrogen it will be 1 by lambda equal to, it will be RH and then Z square 1 by n1 square minus 1 by n2 square. Just this Z square will be inserted. Here also it is there Z square, but for hydrogen it will be 1 square, right? So for 1 square it will be 1 only, right? But in this case, if suppose it is for helium, here it will be 2 square, right? If it is for lithium, it will be 3 square, correct? So likewise, it will get increased. And what is the value of this Rydberg constant RH value? It is 10109,678 per centimeter. This is the Rydberg constant value, correct? But no need to mug it up. They will give you in examination. Might be they will give 109,700. Okay, that is the nearby of this value. Okay, approximate value they will give it. Now, suppose for this n equal to 1, like n equal to 1 for Rydberg value, how you are going to write? It will be minus RH, okay. Here it will be minus n equal to 1 if you are putting here. So it will, what will 1 square, 1 by 1, it will be 1 into RH. So it will be RH, okay. And next, here it will be minus, here it will be minus. And next, for this n equal to 2, how much it will come? N equal to 2. So 1 by 2 square means it is 4, right? So RH by 4. So minus RH by 4. What about this one? It is 3, right? So 3 3s are 9. So RH by 9 minus RH by 9. Here it will be, is n equal to 4. So minus RH by 16. It is n equal to 5. So it will be minus RH by 25. So likewise it will increase. Okay, these are the RH value, Rydberg value. So how you are going to write based on Rydberg value? Now directly you no need to put it here. If suppose you want n equal to 2 and n equal to 1, these two difference if you want, just do subtraction of these two, right? So you definitely will get this value only. Whatever you are getting from here, the same value you will get it from there itself. Correct? So this is the hydrogen spectrum series. Now in this also they will modify and they will ask questions. So I'll just keep it like this only, and then I'll give you one basic formula which is very much required for solving this type of question. Suppose they are asking that just tell me from n equal to infinity to n equal to infinity to ground state, okay. So from infinity to ground state, how many transition will take place? Or maybe they can ask how many emission spectra it can form from infinity to ground state, okay. How many number of emission spectra they might ask you. directly from n equal to infinity to ground state. So now just tell me how like n equal to infinity to ground state, how many it will be? Suppose it is not n equal to infinity, n equal to 5, n equal to 4, n equal to 3. So whether it is n equal to infinity or n equal to, we'll just write nth. Okay, we'll remove this n equal to infinity, n equal to nth. Okay, if it is infinity, from infinity you can't minus anything. So n equal to nth, suppose 5th, suppose 10th, suppose 100th. Okay, from ground state means n equal to 1. So how many number of spectra will be there? Directly it will be based on this formula. So number of emission spectra equal to n minus 1 divided by 2. Okay, suppose you are taking from 5th. Okay, n equal to 5. If you are taking n equal to 5, so from here to here, how many line of spectra it may be formed? So we just calculated 5, and then 5 minus 1 divided by 2. How much it is coming? 5 into 5 minus 1, it is 4 divided by 2. So 20 divided 2. So how many it is coming? 10 it is coming, right? So how you are just writing this 10 value? See, from first emission will be 5th to 1, then 5th to 2, 5th to 3, 5 to 4, and then next will be 4 to 1, 4 to 2, 4 to 3, then next 3 to 1, 3 to 2, next 2 to 1. So how many are there? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why 10 line spectra you are getting, and emission spectra you are getting 10. Now this is from nth to ground state. Suppose they are asking n 5 to n equal to 2 or n 5 to n equal to 3. How many line spectra will be there? Emission line spectra. That also we will solve it. Let's see. Okay, this is direct ground till ground state. So now from n equal to 2 to n equal to 1. Okay, how many number of emission spectra it may be formed? So it will be n2 minus n1, and then n2 minus n1 plus 1 divided by 2. Suppose which 2 I will take? Suppose I will taking from 5th to 2nd. Okay, so it will be 5 minus 2, and then 5 minus 2 plus 1 divided by 2. So it will be 3 into 5 minus 2, it is 3, 3 and 1, it will be 4 divided by 2, so 12 by 2, so total 6 it would be, है Okay, so now we'll just see from 5 to, we'll see the emission spectra, whether it is total number is 6 line spectrum or not. So from 5 to directly 2 it will reach, from 5 to 3, from 5 to 4. Okay, these are the 3, and then from 5 to 2, and then 5 to 3, 5 to 4, and then from 4 to 2, then 4 to 3. Okay, okay dear, yes, and then from 3 to 2. So how many? 1, 2, 3, 4, 5, 6. So in between 5 and 2, how many line spectrum are there? 3, 2 and 1. So 5 and 1, 6. So 6. We got total number 6 line spectrum. Got it? If you have doubt, you can comment it, okay? Or directly you can ask me. I'll give you the satisfactory answer for that particular problem, whatever you are asking, correct? So these are the type of questions that they will ask in the name of quantum chemistry. We are reaching towards now quantum chemistry. So directly we'll go to Heisenberg uncertainty constant. There also you will see some new formulas also, okay? Based on quantum chemistry, you will see some new formulas. Okay, so next topic is Heisenberg uncertainty principle. Okay, Heisenberg uncertainty principle. So in this we know already that delta P and delta X is greater than or equal to H by 4 pi. Okay, and we know that if you are opening this one, it will be like P delta, sorry, it is not P, it will be M delta V. Okay, so mass into change in velocity. Here it is change in position. Okay, if we are multiplying these two factors, we'll get some constant because we can't fix it. What is the change? If we are concentrating on change in position, this will move. The velocity will be the larger difference. The change in velocity difference will be larger. Okay, if we are focusing on change in velocity, the movement, that separation, okay, the separation will be very much large, correct? So likewise, that's why these two we are just multiplying, and whatever we are getting, it's a constant value, okay? Okay, so this is Heisenberg uncertainty principle. Based on this, they might ask you a question directly. They may ask that what is the velocity change, what is the position change, what is the mass, okay, what is the momentum change. So based on this formula only they will ask. This formula in terms of energy and time, okay, this Heisenberg formula, we'll just modify it based on energy and time. So it will be delta E into delta T is greater than or equal to h by 4 pi, okay. So this will be a new type of approach. They might ask you that energy and time, based on energy and time, they might ask you like just find it out the frequency difference, okay. So how you are going to find it out the frequency difference? Just open up this one. Delta E is, we know that it is h into delta nu. This is not velocity, this is nu, okay. Means this is frequency, change in frequency. Now into time, then this will be greater than or equal to 4 pi. So now you just see, if they are asking change in energy, you put this formula. If they are asking change in frequency, then you just modify this with this, okay, and then you can directly solve with this problem, okay. So here one formula is this, second will be this one, and one. So this is a parent formula, and this is a time and energy, okay. In terms of energy and time, you are just changing this formula. So you just write it down, this formula, and practice it, okay. Just will relate one thing, Bohr's theory and de Broglie's equation, both we will relate it and we will just find it out. Sometimes they might ask de Broglie wavelength, right? So de Broglie formula also we know, and if you are just relating to the Bohr formula, you will get this one, right? MVR equal to NH by 2 pi. So this formula will help you out for so many things. This N is number of orbit, like which orbit it is present, so that number. This is Planck constant, okay, velocity, mass. In this unit only formulas are there which you have to practice it, and then when we are solving PYQs, that time it will be like, you will think, okay, oh yeah, whatever this formula we have written, it is useful now, right? Now next we'll see Schrodinger wave equation, correct? Schrodinger wave equation, okay. So what is the Schrodinger wave equation? Dou square psi dou x square plus dou square psi dou y square plus dou square psi dou z square, okay, plus 8 pi square m divided by h square, and then energy minus, this is potential energy, psi equal to 0. And this psi, what is this psi? It is a wave function, okay. Now we are entering towards the wave function. So this is a Schrodinger wave equation, okay. So this formula, directly they may ask that what is the Schrodinger wave equation formula. So you can say that this one, okay, dou square psi dou x square. So these are the coordinate, okay, x coordinate, y coordinate, z coordinate, because this is three-dimensionally Schrodinger wave equation you are writing. If they are asking 1D for x coordinate, what you will do? You take this one and remaining you write. If they are saying for y coordinate, leave these two, you just take this one and write it down this one, okay. If they are saying for z axis, you just write it down this and take these together, okay. Then leave these two. So likewise, if they are asking for three-dimensionally Schrodinger wave equation, then this is the three-dimensionally Schrodinger wave equation, okay. If they are asking for 1D, so they have to mention whether for x coordinate they want, or y coordinate, or z coordinate. Suppose they are not mentioning x, y or z, you just simply writing down the x coordinates value, okay, because by default whenever we are starting for this 3D Schrodinger wave equation, we are starting with the x coordinate. Once we are finishing with the x coordinate, then we are just multiplying with the remaining two coordinates, z coordinates and y coordinates. So we will see this wave function, what is psi and psi square. So psi is your wave function, okay, and it is like with this psi we were not able to find out where the electrons are present, what is the probability of electrons. So what we are doing, this psi we are just multiplying to psi square. If we are just multiplying with the psi square, then we are like giving one region in space where we say that now electrons populations are here. So this psi we can call it psi x and t. So this is a function of time and space, okay. This is a function of time and space. We can say that now the electron density may be in this particular area, it may be present in this particular time, correct. But we can't define that which particular, we can't draw the boundary, okay. With this psi we can't draw the boundary because it's a space and time, okay. With respect to space and time, it is saying that these are the electron cloud, it may be present here, right? But when we are doing this psi square, it will have the meaningful values, okay. Now we can put the boundary. For it is s orbital, we can put a boundary and we can say, okay, in this area only electron density will be present. Suppose for p, we can say that these are the boundary where the electron density will be present, okay. These are the boundary, and in this boundary we can say that actually for p, the actual shape will be like this. Okay, what is the meaning? Because if you are coming towards the center, there won't be any electron, because see, this is a pointed, correct? If you are going towards the distal part, you will see the electron density, correct? So this is the meaning of psi square, okay, that it is just giving a boundary to you where the probability of electron, okay, maximum probability to finding an electron is this place, okay. This it is saying by psi square, correct? So just we'll see, this is a amplitude, okay. Just we'll draw a graph and then we'll see what is the like amplitude relation, okay, with the space and time. This will be psi versus your distance from nucleus, okay. R is distance from the nucleus and psi is your amplitude. So this is one graph. So this is psi, okay, and psi is amplitude. You know the amplitude in wavelength, right? So and this side it is distance from nucleus, okay. Suppose this is nucleus, okay. Here the distance of r is 0. Now for 1s, if you are writing, so we know that for 1s like this, okay. So this is the distance for 1s and there won't be any nodes for 1s, okay. I'll give you the formula to find out the nodes, okay. Angular nodes, radial nodes, total nodes, everything I'll just give you. First see this graph, okay. And for 2s, this will be for 2s, this is 1s, this will be for 2s. You see one node it has arise, okay. And for 3s, okay, for 3s we are just drawing for 3s. See, this is for 3s, okay. So see, one node is here, another node is here, okay, and then so total 2 nodes are there for 3s, correct? So this is for s orbital, we have just drawn it out, okay. Likewise for p, if you want to draw, you can draw it for p also. This is psi and this is amplitude, we call it. So what is this amplitude? This is the amplitude value, okay. This value is psi, correct? So now just we'll see for p, right? So p will start with 2p. So here we'll just write it down. This is the r value, this is amplitude, okay. It will start with 0, okay, from center. Now for 2p, this is for 2p, and for 3p, this is for 3p, one node we found out. And for 2p, we don't have any node, okay. So we'll just calculate how to find a node. So this type of graph, if it is showing, just you have to find it out for, this is for 1s, okay. This is for 2s, okay. And this is for 3s. So just see the nodes, number of nodes it is forming, and based on that you have to just find it out. So the particular graph or particular plot is belonging to which orbital, okay. So this is for p we are drawing, okay. Likewise we can draw for d and f also. So let it be for s and p only, because it won't go for u, it won't go for d and f, okay. Now we'll see the number of nodes, okay, total number of nodes, and then we'll see your particular angular nodes, and we'll see your what we call radial nodes, okay. For hydrogen wave function, I'll just write psi wave function, the number of nodes, how you find the nodes, okay. So first we'll just calculate for your radial nodes, okay. So number of radial nodes, how you are going to find number of radial nodes? N minus L minus 1, okay. What is N? N is principal quantum number, L is azimuthal quantum number. Okay, this is 1. Okay. Suppose for 3p you are finding. Okay, 3p. So for 3p, how many radial nodes will be there? 3 is n equal to 3. So 3 minus L equal to p. So p. So 0, 1, 2. So S, P, D. So if it is P, it will be 1. So 1, 3 minus 1, and then automatically already we have 1. So it will be 3 minus 1, 2, 2 minus 1, 1. So how many radial nodes will be there? Only 1 radial nodes. Okay. Likewise for angular nodes, angular nodes will be the angular nodes will be equal to L, right? So what is the, for 3p, number of angular nodes will be, so P means it is 1, right? So number of angular nodes will be 1. Again, number of angular nodes will be 1. So now for third, total number of nodes. Okay, for this 3p, if we are finding total number of nodes, it will be your n minus L. Okay, so n minus L. So 3 minus, what is the value of L for this 3p? It is 1. So how much it is coming? 2. So see, total number of nodes is 2. Here also see, radial nodes is 1, angular nodes is 1. So 1 and 1, it is 2, right? So here also we are getting 2. So this formula, you just remember it. N minus L minus 1, radial nodes, angular nodes equal to L, and total number of nodes equal to n minus L. Okay, based on this, they have asked one question. Now we will take up the questions. Okay, from 2022, we have question number 24. See in the screen. Okay, I'll rub the board. So in this question, you just see that they are giving transition. Okay, 2022 question number 24. The ratio of the 2p to 1s. Okay, 2p to 1s transition energy in helium to that in the hydrogen atom is closest to. Okay, they just need the ratio of transition energy. Okay, transition energy of helium plus to hydrogen. Okay, energy of helium plus to energy of hydrogen. These two energy, because we know that energy formula, right? So in that energy formula, you have to just put it this value and you will get the final answer. Formula, so we already know, minus 13.6 Z square N square, and this is in electron volt, right? So for helium and for hydrogen, we'll put it. So what will be the change? This will be the constant term. And for helium and hydrogen, both will have n equal to 1. Okay, first Bohr orbit only it will be having. Only this value is getting changed. So what we will do it, just put here this value, minus 13.6 into Z will be your 2 square divided by minus 13.6 into your Z will be 1 square. Okay, and if you want, divided by 1 square and divided by 1 square, this n square, right? So this will get cancel it out, this will also cancel it out. So how much it is coming? 2 to the 4, and this is 1, so 4. Okay, so answer will be 4. You see, option C will be your correct answer. Okay, now next question we will take it up from the same year, question number 28. Okay, question number 28. Okay, so one dimensional box question. Okay, so generally you will get till one dimensional box only. They will not ask you for 2 dimensional and 3 dimensional, I suppose. Okay, so this question number 28. Okay, not difficult but lengthier one, correct? This type of question you solve at last. If you are finding time, then only you solve, otherwise leave it. Okay, so just go through with line by line. The potential for a particle in one dimensional box, if it is given one dimensional, means whatever you are just doing, that will be in x direction. Okay, so likewise decode the question and then we'll solve it. Okay, so potential for a particle one dimensional box, already we have written. Then Vx, the potential energy it has given. Okay, it is 0 for x is lesser than, x is greater than or equal to 0 or lesser than or equal to L. This condition they have put. Okay, greater than or equal to x and then lesser than or equal to this L value. And when Vx equal to infinity, it will be in elsewhere. Okay, there won't be any condition. Whenever the Vx equal to 0, this particular like condition it is applying, that x position. What is this x? X, you will see that number of like position of your nodes. Okay, it will the x means it is asking the position of node. Maybe the question I'll see the complete question, if I am seeing, then only we'll come to know. So position of node is asking. Okay, so what will be the position of node? It will be greater than 0 and lesser than this L value, equal to or lesser than this L value and greater than or equal to this 0. Means this position of node can't be 0. It means it is not asking for 1s, it is not asking for your 2p, or it is not asking for your 3d where the nodes are not present. Okay, it is not asking those position. It may be 2s, 3s. Okay, so likewise. So next condition they are giving something like the location of internal nodes of the eigenfunction. Okay, they are saying just location of internal nodes. Just see what is the location they are giving. N is greater than or equal to 2. Okay, and one more condition they are given, 0 is greater than m is greater than n. Okay, so here the n they have given, a principal quantum number they are giving. Okay, so in this principal quantum number you have to see how many nodes it may be present. Okay, and it should be greater than or equal to 2. So we can take it 2, n equal to we can take it 2, n equal to we can take 3, 4. Likewise we have to take it, but 1 and 0 it won't be possible. So 1 we can't take it. So 2, 3, 4. So in that place, if you are taking n equal to 2, your m value will start with it never be 0 because it is greater than 0, and it will be lesser than n. If you are taking n equal to 2, then your m value will be 1, right? If you are taking n equal to 3, your m value will be 1 and 2, correct? If you are taking n equal to 4, your m value will be 1, 2 and 3. So likewise, because it should be lesser than your n, right? So now we have to solve it. All the condition we have got to just draw it out, and we know that if you are taking n equal to 2, your number of nodes will be n minus 1, right? So it will be n minus 1. So 2 minus 1, it will be 1, right? So here one node should be drawn out. Okay, so here one node we got it. This is node only. Okay, and they are getting like the function they have given with L. Okay, so distance they are giving just L. So this place, if it is L, then what will happen? This will be your L by 2. This will be your 0 point. If you just divide it, this will be your L by 4. This will be your L by 4. Then it will be L by 2. This will be your 2L by what we call 4. No, not 2L by 4. It will be your 3/4, right? So 3L by 4, and this will be your L. Okay, this value you are getting because x will be greater than or equal to L. Okay, x will be greater than or equal to L, but it will be again, it will be greater than or equal to 0 also, right? So now just solve it for this. So here we have this is for psi 2, right? So n equal to 2 we are just finding out. Here n equal to 2 we are just finding out. Okay, so how much it will come? So if you are taking n equal to 2, your m equal to how much it will be? 1, right? If you are taking n equal to 2, see, if n equal to 2 you are taking, so your m value will be 1. So now just option we have to see the x equal to, if we are putting m plus half by n, so m plus half. So if m value is 1, then 1 by 2, and then n value will be your 2. So how much it is coming, just see, and that much L. So this is the position of node, x is position of node. So this value after solving it should get L by 2. So out of this 4 option, we have to see which option is showing L by 2. Your solution will be L by 2. Okay, so first solve this one. So it will be 3 by 2 divided by 2L. So it will be 3L by 4. So 3L by 4. But position of node is not in 3L by 4, right? The position of node is in L by 2. So option A is wrong. Let's go for option B. What it has given, x equal to m by n into L. So m position is 1, n position is n is 2, and L 1 by 2 L means L by 2. So whether position of node is L by 2? Yes, position of node is L by 2. So our option B will be correct. So 28, it is not MSQ, it is MCQ. So question number 28, option B will be your answer, correct? So likewise you have to solve it. So it will take time, okay, but you will get your answer. Suppose what we have to do it, just draw it for n equal to 2. It has given greater than, okay, any value you can take it. If you want 3, you can take it 3. If you want 4, you can take it 4. And then you just draw it out this value and try to find it out, because this x, they want the position of because they have said the location of the internal nodes of the eigen function, okay. So this internal nodes you have to find it out. So just one by one you just put the formula. For a I have put in, it is coming 3l by 4, but 3l by 4 there is no nodes, okay. Second, for option B we have calculated, it has came l by 2, so the position of node in l by 2, right? So it means this option B is correct. So we'll take up the next question. Okay, so next question we'll see. So next question is from 2021, question number 4. Okay, 2021 question number 4. Okay, it is very easy question. Question number 4. By seeing only you will solve it. Two sets of quantum numbers with the same number of radial nodes. They are asking radial nodes. Number of radial nodes. Okay, what is the formula of number of radial nodes? N minus L minus 1. Just put this formula. For option A, we will put it. First 3. So 3 minus L value is 0. So 3 minus 0 minus 1, it will be 2. So first part. And second part, N equal to 2. 2 minus 0 minus 1. So it is 1. So this one and this one is not same. So option A is wrong. Option B, it is asking with the same number of radial nodes, right? Option B, N equal to 3. So 3 minus L equal to 1. 1. And already we have in this formula 1. So it will be 3 minus 1 minus 1. It will be 2 minus 1, 1. And then second part is N equal to 2 minus L equal to 1 and minus 1. So how much it is coming? It will be 0. So again this one and this one is not matching. So this won't be your answer. Option C, N equal to 3 minus L equal to 2 and minus 1. So it is coming 0, right? 3 minus 2 minus 1, it is 0. And the second part, N equal to 2 minus L equal to 1 and then this formula 1. So how much it is coming? 2 minus 1 minus 1, it is 0. So these two are same, right? So option C will be your answer. Let me check option D also. Option D, N equal to 3 minus L equal to 1 and then formula 1, right? So how much it is coming? 3 minus 1 minus 1, it is 1, right? And the second part, N equal to 2, L equal to 1 and the formula 1, if you are minusing, it will be 0. So this one and this one is not same. So option D is not your answer, correct? So option C will be your answer. So if they are asking radial nodes, next time maybe they will ask angular nodes or maybe they will ask total number of nodes, correct? So likewise we are solving. So next question we will take it up. It is from 2020, question number 32. Okay, 2020 question number 32. So in the name of quantum chemistry, they will ask this type of question, correct? So it is not that much advanced level quantum chemistry they will ask. Okay, so question number 32 from 2020. They have given psi xyz, okay, coordinate x, y and z coordinate, the wave function in x, y, z coordinate. Describe the wave function of a particle. Okay, just draw that particle. Okay, this is a particle, this is x, this is y and this is z coordinate. This is a particle. The probability of finding the particle between x and x plus dx, in between the x and x plus dx. So suppose this is a x plus dx and y plus dy. So y and y plus dy. This is dx, okay, small amount of distance. Here also small amount of y dy. And then z and dz, okay. So this you have to just imagine, because this z is this place. So from here to, it will directly go from this place to this place, okay. How we will draw it? You have to just imagine it. Okay, this is dz, correct? Can be expressed as, okay, d tau. This entire thing will be your this value, okay, d tau. D tau means you will have both the dxy, dy and dz, okay, both तीनों कोऑर्डिनेट यहाँ पे रहेगा, इसीलिए इसको हम लोग d tau बोलते हैं. d tau में क्या रहता है आपका? dx रहता है, dy रहता है और dz, तीनों एक साथ रहता है, उसको d tau बोलते हैं. Okay, together, all together it will be the d tau. So first option psi Okay, this is the complex conjugation, psi and x, y, z multiply with psi, x, y and z. It won't be there because here this one is missing, correct? And here for option A, what happened? They have not taken this dx, they have not considered this dx, dy and dz. So this option won't be correct. It is saying that in space, okay. This also explaining that it is in a space, one point is there, okay. But from this equation 1, equation A, it is considering that it is a point mass. It's not having any volume, okay, from this, because they are not taking any volume, but we have volume, right? Dx, dy, dz. If you are multiplying, we are getting d tau. So that should be fulfilled in the option, then only it will be your correct option. So option B, we will see it. They have given magnitude of x, y and z, and then this square, okay. Then see dx, dy and dz they have taken. So it means they have taken, this is a point, like this the coordinate square, this because this is psi square. Psi square is a probability of finding an electron, okay. It is very near that this much area the electron will be here, and we are giving that also, that this is the place where the electron probability will find. And what is the volume? Dx, dy and dz. So this option will be correct, okay. And option C, we'll see it, option C. So this is a conjugation complex, x, y and z, and then normal psi, x, y and z, okay, multiplying with dx, dy, dz. See, this same thing is missing, it was missing here, right? So this one we are considering as a point mass. You just see next time, next time if same question they are asking, and if they are not giving this dx, dy and dz, this will be your correct answer, okay. But if they are giving dx, dy, dz, then you have to find it out this d tau. Instead of this, you can write d tau also, okay. I don't know why they have not given, they might given this equation also, right? Psi, x, y, z, and then this mode, and then d tau. This is also one option. If this is also there, this will be also your correct option. They may write in this place like this style also, x, y, z, and then they may write a psi, x, y, z, and then they might write d tau. This will be also your correct option, right? If they are writing in this style also, this is also correct option, this is also correct option. These are not there in your question paper. Just I am telling you, if they are giving like this will be also your correct answer, okay. D tau means dx, dy, dz only, okay. That the volume, small area of like small volume, okay. And then option C is also your correct answer. What about option D? This is multi-selection question. Option D also it is not correct because it is taking minus infinity to infinity. So this is not minus infinity to infinity. We have a particular area dx and dy and dz, right? So no need to go from minus infinity to plus infinity, correct? So just remember this one. Option B and option C will be your correct answer for this particular question. Is there any other question in this particular year 2020? Question number 42. Okay, what is there in question number 42? So question number 42, we'll solve it. It's a numerical aptitude type question. I'll just solve it. Okay. What they have given? The longest wavelength. See, if they are writing longest wavelength, it means the shortest energy. Okay, longest wavelength means shortest energy. In hydrogen spectrum, where the shortest energy is there, n equal to 2 to n equal to 1. Okay, emission spectrum, n equal to 2 to n equal to 1. This will be the shortest energy and longest wavelength, correct? Now next we'll see what they have given. Light absorbed by a hydrogen like atom is 2.48 nanometer. So n equal to 2 to n equal to 1, they are saying that they have absorbed 2.48 into 10 to the power minus 9 meter wavelength. Okay, you can easily convert it to the energy. Okay, then the nuclear charge of the atom is, okay, the nuclear charge it is asking. Okay, nuclear charge means they are asking Z. Okay, what will be the number of proton there. So number of proton is directly proportional to the number of Z. Okay, so we know one formula, this one, okay, that frequency equal to 1 by lambda, or directly we can write RH and Z square 1 by N1 square minus 1 by N2 square. Just put those values, you will get the answer. Okay, so 1 by lambda 1 by 2.48 into 10 to the power minus 9 equal to RH. Whether they have given RH or we have to take it up. Okay, they have given RH. This is 109,700 per centimeter. Okay, this value they have given, and then this will be Z square. Here it will be N1 will be your 1 square minus N2 will be your 2 square. Okay, so how much it is coming? Let's see. It will be 1 by 2.48 into 10 to the power minus 9 equal to 109,700 into Z square. Here it will be 1 by 4 minus 1 by 4, so it will be minus by 4. Directly I am just calculating because this is 1 minus, it will be 1 by 4. Okay, it won't be 4. Wait, it will be, just I'll solve it here. 1 minus 1 by 4, so it will be 4, and then 4 minus 1 by 4, so it will be 3 by 4, right? Minus 3 by 4, so minus already we have put here, so here it will be 3 by 4. Just do cross multiply. Okay, how much it will come? Z square equal to it will be 4. Okay, this 4 will go up, and Z square remaining it will be in down. 2.48 into 10 to the power minus 9 into 109,700. Okay, and into 3. So how much it is coming? Already I have calculated. Let's see. It will be your 49.01. Okay, 49.01. Now we have Z square. So what about Z? It will be under square 49.01. So approximately you are getting 7, right? 7 7 ja 49. So 7. So your correct answer will be 7, right? So we'll see the next question from this particular year. We won't have any other questions for 2020. 2019 we'll see. Okay, question number 58. Very easy. You see in the screen, by the time I'll rub the board, I know you will give me the answer, right? It's a simple. Okay, so likewise questions they are asking. Okay, question number 58 from the year 2019. Given that the radius of the first Bohr orbit means n equal to 1, just write it down. First Bohr orbit of hydrogen atom means Z equal to 1 is 53 picometer. Okay, how much radius is 53 picometer? Okay, the radius of its third Bohr orbit, so n equal to 3. Then what about this is n equal to 1. Okay, R1. If R3 if you want to find, how much it will be? Okay, for third Bohr orbit is, so and any condition round up to the nearest integer. Okay, so R3 is R equal to 0.529 into n square divided by Z, and that will be in angstrom, right? So we don't want in angstrom, so we'll just write the picometers formula, correct? The picometers formula, it will be like 53. They have given 53 for first Bohr orbit into your n square divided by Z, correct? So how much it is coming? Whatever it will come, it will be in picometer, right? So 53 into n equal to 3 they want. So 3 into 3, it will be 9 divided by Z will be always 1, right? So it won't affect anything. So how much it is coming? 7, 45 and 2, 47, 477 picometer will be your correct answer, right? So 477 picometer will be your correct answer, correct? So we have solved all the questions, like we have not left any questions from this atomic structure and quantum chemistry. So don't worry about that. Those big, like you are seeing all the classes, right? The big formulas, big quantum numbers, quantum mechanics. It is for GATE and CSIR, correct? For you, this much basic requirement is there. You just go and see your syllabus also, right? What modification they have done in your syllabus, that is also very much important, right? And 1 or 2 questions they are asking. So based on that, you will solve these questions. Whatever concept I have given, based on that, you will be able to solve this quantum mechanics question also. Okay. So thank you very much for watching.